some of you may know, I've been working on a Paintball Sentry gun, and I wanted to give you guys an update on how it's been progressing. It isn't done yet, but I finished writing the motion tracking class a few weeks ago. I've been testing and debugging it lately, so this is what I've got so far. First thing I'm going to do is open up Microsoft Visual C++ Express Edition. I open up my Paintball Sentry class, Sentry project, and I am using OpenCV, which is a free library that you can use with your C++ projects to use cameras, capture images. Up here I'm using my motion track. This is the classes that I wrote: motion track, frame, and 3D targets. So I'll show you the heart of the program, which is down here. It's these 6 lines. First you capture the frames using your CV, and it reads the frames. You get the time that the frames are read. You pass in those frames into a frame that I've created, and then those frames are passed into a motion track class, which analyzes them and then returns a vector of 3D targets. And that is pretty much the entire heart of the program. It just loops through this and keeps passing back targets. So I'm going to run it now. You have your location, X, Y, and Z, direction, X, Y, and Z, your speed, your distance. Direction's not going to matter because these objects aren't going to be moving in this demonstration. Speed's not going to matter because the objects aren't going to be moving. And the Y location's not going to matter because it's going to be on a kind of like a 2-dimensional board. So it's just going to be X and Z that they're going to be on. And the distance will be accurate. And then here's your list of targets. So if you have multiple targets, they'll show up here. The largest target will be shown on this display, and it'll show you your X, Y, and Z for that list. So we'll go into settings. Now this has all been set up the way I wanted for this demonstration. I have to give you a heads up. I manually calibrated this, so it's not 100% accurate. Also, I am using low quality cameras, 640 by 480 by resolution, which is pretty low, and it'll be much more accurate if you use a higher resolution camera. It'll be slower, but it'll be more accurate. So that's what we have there. So before I run it, I'm going to give you a demonstration on the board and how I have that set up.
So this is the board that I use for testing. It's a scaled down version because it is winter outside and you can't do any really good testing out in the snow, so this is what I do it. And I've got my two webcams set up here. They are 5 inches apart in parallel, and this is my board. All the spaces are 6 inches. Got -1, that's the Z, -2, -3, all the way down to -10 way at the end. I got 1, 2, 3, and -1, -2, -3, and that's the X. And then I've got 2 cans here. I also have a SpongeBob character that I'm going to be using for objects. I'm going to be placing them on the board, and hopefully my program will pick them up and tell you where they are roughly. So this is what I'm going to be testing it on. And the camera is going to be positioned directly behind this while I'm doing this, so you should be able to see as I'm setting them down where I'm setting them and what the program is showing. So that's all. So for this test, first test, I'm going to set a can at 1, -5. Getting pretty close. Set it at 0, -7. Pretty close. set way out at -2, -10. Not too bad. X is a little off at 1.6, but overall, it's not too bad. Now for this test, I'm going to use multiple objects, see how it does tracking multiple objects. They can't cross each other, they can't block each other, otherwise it won't work, but it should work. So I'm going to set one at 1, -5. I'm going to set one at, let's go -2, -8. And I'll set SpongeBob at 0, -6. There we go. 3 targets, and it should track them all pretty accurately.